Welcome to the lecture series of Engineering Mathematics. I am UV Manoj Kumar, Assistant Professor of Mathematics, Vignan's Foundation for Science Technology Research, Vadlamudi. Today, I am here to discuss Unit 3 of Engineering Mathematics. Unit 3 is first order, first degree, ordinary differential equations. Our third unit consists of the following topics. So, in this third unit, we will see definitions, formation of differential equations, and first order, first degree differential equations of different types like variable separable, homogeneous, linear, Bernoulli, exact, and non-exact types. So, why we study differential equations? Where these differential equations are applicable in our life? So, differential equations are applicable in each and every part of physics which deals with a rate of change. So, whenever there is a rate of change in a physical phenomena, that can be represented by a differential equation. So, we can come across these differential equations in the following fields. In fluid dynamics, Navier-Stokes equations are partial differential equations which are highly nonlinear, whose equations are very much useful for predicting flow of a fluid of described phenomena. Similarly, we can use differential equations in semiconductor modeling, reaction diffusion equations, digital image processing, socio-economic modeling. Outcomes of Unit 3. After completing this unit, students are able to, first they can identify what is the type of the differential equation, they can form differential equation, they can solve a given differential equation by suitable method. Let us come to the definitions. What is a differential equation? So, we are saying differential equation. So, first it should be an equation. It should be an equation and it should involve derivatives. Derivatives of a dependent variable with respect to independent variable. Therefore, so what we can say a differential equation is? A differential equation is an equation involving derivative of a dependent variable with respect to one or more independent variables. So, the derivatives are also called as differential coefficients. If you are differentiating once, we will get a first order derivative. If you are differentiating twice, we will get a second order derivative. If you are differentiating thrice, you will get a third order derivative. So, all these first order, second order and third order derivatives are called differential coefficients, and an equation which is involving these differential coefficients is said to be differential equation. When you are finding a derivative, there will be a dependent variable and a independent variable. Independent variables may be one or more, but most of the times we will come across with only one dependent variable. Suppose if I am writing dy by dx, y is dependent variable, x is independent variable. If I am writing dy by dx, I am differentiating y with respect to x. So, how many times I am differentiating here? Only one time. So, dy by dx will be first order derivative. Similarly, d square y by dx square will be second order derivative of y with respect to x. Likewise, we will have different orders derivatives of dependent variable y with respect to x. A differential equation involves derivatives, or derivatives are also called as differential coefficients. So, a differential equation is an equation involving derivatives of a dependent variable with respect to one or more independent variables. an equation involving a dependent variable and its derivatives with respect to one or more independent variables is called differential equation. Here are some examples. So, if you see these examples, first example is dy by dx plus 5y equals to e power x, d square y by dx square minus dy by dx plus 6y equals to 0. Dou square u by dou x square equals to dou square u by dou t square minus 2 into dou u by dou t. So, if you observe these three differential equations, they are different. What is the difference between them? How they are different? So, if you consider the first equation, here we have one dependent variable. What is the dependent variable? Here the dependent variable is y and independent variable is x. Here dy by dx is a first order derivative. So, this equation is involving first order derivative dy by dx, whereas the second equation, second differential equation is involving second order derivative d square y by dx square and first order derivative dy by dx. So, these two are ordinary differential equations. Why they are called ordinary differential equations? We will see. And this is called a partial differential equation. Why? Because it is involving partial derivatives. So, here if you see, u is the dependent variable. We are differentiating u with respect to x here. If you see the LHS, dou square u by dou x square, you are differentiating u twice with respect to x. Whereas if you see the RHS, we are having dou square u by dou t square. That means u is differentiated with respect to t twice. That means here t is the independent variable, whereas here x is the independent variable. So, there are two independent variables, and how many dependent variables are there? U is the only dependent variable. So, what is the dependent variable here? U is dependent variable, x and t are independent variables. So, what is the difference between these three examples? In first example, we have an ordinary derivative of first order. What is that? Dy by dx. There, dependent variable is y, independent variable is x. Okay. In the second example, we have second order derivative, also first order derivative. What is first order derivative? Dy by dx. What is second order derivative? D square y by dx square. So, here also there is only one dependent variable y and one independent variable x. But if you see the third example, dependent variable is u, but there are more than one independent variables. What are they? X and t. So, here also we are having second order derivatives and also first order derivatives. Okay. These three are examples for differential equations. Not only these three, we can have many examples, and we should remember the definition. What is the definition? A differential equation should be an equation involving derivatives. Derivatives of what? Derivatives of a dependent variable with respect to one or more independent variables. So, a differential equation is an equation which involves derivatives of a dependent variable with respect to one or more independent variables. Okay. Next, what is ordinary differential equations and what is partial differential equation? So, an ordinary differential equation will consist only one independent variable. So, one independent variable. If a differential equation consists only one independent variable, then it is said to be ordinary differential equation. So, see the examples there. Two examples are given. Those two examples represents ordinary differential equations. So, if you see the first example, d square y by dx square minus dy by dx plus 6y equals to 0. Here, dependent variable is y, independent variable is x. How many independent variables are there? You see the derivatives here, d square y by dx square. In the denominator, x is the variable, minus dy by dx. In the denominator, x is the variable. So only one independent variable. What is the dependent variable? Y. We are finding derivatives of y. So y is the dependent variable. So this is an ordinary differential equation. Why? It is having only one independent variable, x. Similarly, if you see the second example, there dx by dt plus dy by dt equals to 2x plus y. Dx by dt plus dy by dt equals to 2x plus y. We are differentiating x with t, and also we are differentiating y with t. So here x and y are dependent variables, whereas t is independent variable. So our condition is on independent variable. Since the differential equation has only one independent variable, it also comes under ordinary differential equation. Okay. What is partial differential equation? An equation, a differential equation involving derivatives of a dependent variable with respect to two or more independent variables. Independent variables should be two or more. Such differential equation is said to be partial differential equation. Differential equation that involves two or more independent variables are called partial differential equations. So when you are saying a differential equation is partial differential equation, there should be minimum two independent variables or more also. Okay. See the examples given here. So dou u by dou y. What is independent variable there? Y is the independent variable. Equals to minus dou v by dou x. What is the independent variable? X is the independent variable. So this equation, this differential equation is involving two independent variables, y, x. So therefore it is partial differential equation. Also if you can see this partial derivative is there. So partial derivative also there. Okay. See this example, second example. Here x, t are the independent variables. So these two are partial differential equations involving two or more independent variables. Order of a differential equation. The next definition is order of a differential equation. What is the definition? We say order of a differential equation is n if the highest order derivative occurring in the differential equation is nth ordered. Suppose, see these examples. So in the first example, what are the derivatives we have? Here y is the dependent variable. Dy by dx, d square y by dx square are the derivatives of y with respect to x. Dy by dx, we are differentiating y with respect to x for one time. So that is first order derivative. D square y by dx square is second order derivative. So in the differential equation, what is the highest ordered derivative? D square y by dx square is the highest ordered derivative. What is its order? 2. Second order derivative. So order is 2. So therefore differential equation order also becomes 2. What is the definition? Order of the differential equation is nothing but order of its highest derivative. Order of the differential equation is nothing but order of highest derivative occurring in the differential equation. Similarly, if you see dy by dx whole power 4 plus y equals to 3. So here only one derivative is involved, and that is first order derivative. This is power, 4 is power. We are not discussing about powers, we are discussing about orders. Order means how many times you are differentiating. Dy by dx, we are differentiating only once. So order is 1. Okay. The next definition is degree of a differential equation. The degree of a differential equation is the highest power of the highest order derivative after it is expressed in a form free from radicals, fractional powers. Okay. So the power of the highest ordered derivative in the given differential equation when it is free from the radicals is called as degree of the differential equation. So whenever you are discussing about the degree of the differential equation, you should see that it is free from radicals. It is free from radicals. It should be free from fractional powers. Suppose if I have a differential equation like d square y by dx square whole power 3 by 2 plus 2y equals to 3. If I have a differential equation like this, and if I ask you what is the order for this differential equation, what is the degree for this differential equation, then what is the order? Answer me. So since we have second order derivative and it is the highest order derivative in the equation, order is 2. Okay, what is the order of this differential equation? Order is 2. Okay, what is degree of this differential equation? When you want to tell me degree, you should express it in a form free from radicals, free from fractional powers. So if you see, this is a fractional power. 3 by 2 is a fractional power. So we should take care to make it a not fractional power. How to do that? We want to square on both sides. If you square on both sides, 3 by 2 into 2 becomes 3. So after it is expressed in a form free from fractional powers, highest power of the highest derivative will be 3. Okay, clear? So here highest derivative is d square y by dx square and its power is 3 by 2. Okay, 3 by 2 is a fractional power. I don't want fractional powers. What to do? So in order to remove this by 2, I am squaring on both sides. When I square this on both sides, 3 by 2 into 2 will be the power, 2 gets cancelled, and what will be the power? 3. So therefore degree will be 3. So for this differential equation, order is 2, degree is 3. Tell me order and degree of this differential equation and this differential equation. Already these are examples we have seen when we are discussing about order. So this is second order, this is first order differential equation. So what is about its degree? Degree is the highest power of the highest ordered derivative. What is the highest ordered derivative? In the first example, highest ordered derivative is d square y by dx square. What is its power? 1. So what is the degree of the first example? 1. What is the degree of the second example? Here highest derivative is dy by dx and its power is 4. So here degree is 1, whereas for second example degree is 4. Okay, so far we have seen some definitions. What is ordinary differential equation? What is partial differential equation? What is the order of a differential equation? What is degree of a differential equation? Also we have seen what is a differential equation. Now we will go to the topic of formation of differential equations. So how differential equations are formed? How differential equations are formed? Differential equations will be formed when we are trying to model a physical problem into a mathematical expression. If I want to express a physical problem through a mathematical equation, this process will involve differential equations. So differential equations are formed in the process of modeling physical processes. Okay, so mathematically, if you want to tell mathematically a differential equation will be obtained by eliminating arbitrary constants from the given expression, from the given relation. Okay, so if I am given a expression involving two arbitrary constants, I will try to eliminate these two arbitrary constants, and in this process of elimination of arbitrary constants, we will form differential equation. So here there is a note which is important for us. What is this note saying to you? In general, nth order differential equation will be formed if the function is having n arbitrary constants. So if you have a function with n arbitrary constants, by eliminating all these n arbitrary constants, we will get nth order ordinary differential equation. So you should remember that condition. So if you have n arbitrary constants, you will get a nth order ordinary differential equation. Okay, see the example here. Here I have the expression y equals to a sin x plus b cos x. Y equals to a sin x plus b cos x. In this, a and b are arbitrary constants. So the expression y equals to a sin x plus b cos x has two arbitrary constants. I want to eliminate these arbitrary constants capital A and capital B. So what I have to do? Because there are two arbitrary constants, you differentiate this relation twice with respect to independent variable. What is independent variable? If you see this expression, y is expressed in terms of x. So y is dependent variable, x is independent variable. So differentiate it twice with respect to x. So when you are differentiating for the first time, so y derivative is dy by dx equals to a into derivative of sin x is cos x plus b into derivative of cos x is minus sin x. So the first derivative is dy by dx equals to a cos x minus b sin x. So since there are two arbitrary constants, we should differentiate two times. So again differentiate this relation with respect to x. So derivative of dy by dx becomes d square y by dx square equals to a into cos x derivative minus sin x minus, as it is you write, b into sin x derivative cos x. If you see minus, if you take common from this, you will get minus of a sin x plus b cos x. If you take minus common, you will get minus of a sin x plus b cos x. That is nothing but your minus y. Because what is y? A sin x plus b cos x. So this becomes minus y. So d square y by dx square equals to minus y, or if you bring that minus y to the other side, the resultant differential equation is d square y by dx square plus y equals to 0. So in this way, we form differential equation. If the given relation is having two arbitrary constants, you differentiate twice and try to find out an expression without a and b which involves derivatives. Try to find out an expression, a relation without arbitrary constants a and b and which involves derivatives. So what is the differential equation here? D square y by dx square plus y equals to 0. So what is the key point here? When you are forming differential equation, if the given relation have n arbitrary constants, if the given function, given relation has n arbitrary constants, then the resulting differential equation is nth order differential equation. So the resultant differential equation will be nth ordered if there are n arbitrary constants. 2 arbitrary constants implies the second order. 3 arbitrary constants implies third order. Likewise, okay? Now come to the topic of first order, first degree ODE. So this is the major topic that we are covering in this particular unit. So here we want to solve different types of first order and first degree differential equations, ordinary differential equations. So the general form of the first order first degree differential equation is in the form f of x y dy by dx equals to 0. What is this expression? You are dealing with first order first degree differential equations. So here x is independent variable, y is dependent variable, dy by dx is derivative. dy by dx is derivative of first order. So an expression which is involving first order derivative and dependent and independent variables is in this form. Not only this, we also want first degree also. We also require first degree. So there should not be any powers of dy by dx. Okay. So the first order first degree differential equation will be in the form f of x comma y comma dy by dx equals to 0. So we will solve different types of first order first degree differential equations in this unit. So what is the basic thing you have to learn and understand is that if I give you a first order first degree differential equation, you should be able to identify appropriate method to solve that. If you are able to do that, then our unit objective is reached. Okay. So what are the different first order first degree differential equations we have? So before seeing that, why we are discussing all this? We want to find the solution of a differential equation. So let us first define what is the solution and how many different types of solutions are there for differential equations. What do you mean by solution? A solution should satisfy the given differential equation, that is the primary condition. A solution should be a relation between x and y. What are x and y? Dependent and independent variables. So a solution should be a relation between dependent and independent variables that satisfies the given differential equation. And also it should not involve derivatives. Solution should not involve derivatives. So that is the definition of solution. What is solution? Solution of a differential equation, DE is differential equation, is a relationship between dependent and independent variables. Solution of a differential equation is a relationship between dependent and independent variables which satisfies the given differential equation. And it should not involve derivatives. Okay. See some example given here. Y equals to e power x is the solution for the differential equation d square y by dx square minus y equals to 0. Is it? Can you tell whether this example is correct or not? So what is y? E power x. What is dy by dx? Derivative of e power x is e power x. What is d square y by dx square? Again e power x. Y is e power x, dy by dx is e power x, d square y by dx square is also e power x. So is my differential equation satisfied? Yes. Both y is e power x, d square y by dx square is e power x. E power x minus e power x equals to 0. So this is solution. So solution should do what it should do. It should satisfy the given differential equation. Okay. So here y equals to e power x is a solution for that differential equation d square y by dx square minus y equals to 0. general solution. General solution is also a solution. Solution means satisfies the differential equation. General solution is also a solution, and it involves arbitrary constants. What is the general solution? General solution involves arbitrary constants. How many arbitrary constants? Number of arbitrary constants should be equals to order of the differential equation. So, a general solution of a differential equation is a solution which involves arbitrary constants. And how many arbitrary constants should be there? The number of arbitrary constants involved should be equals to the order of the differential equation. So if you see the same example, d square y by dx square minus y equals to 0. So here the general solution is c1 e power x plus c2 e power minus x. So here how many arbitrary constants are there? c1, c2. Two arbitrary constants are involved in the solution. So since the given differential equation is second order and the solution has two arbitrary constants, this is called general solution. Why it is general solution? It is involving arbitrary constants. Remember, for a given ordinary differential equation, there will be only one general solution. Therefore, we will always say the general solution. Solutions may be many. E power x is a solution. E power minus x is a solution. 3 into e power x is a solution. Many solutions are there. But the general solution is unique. So therefore, there will be only one general solution which involves arbitrary constants. Next one is particular solution. How you will get particular solution? The particular solution is obtained by assigning values to arbitrary constants in the general solution. In the general solution, there are two arbitrary constants C1 and C2. If you are able to find out those C1 and C2 by applying some physical conditions, and if you get the values of C1 and C2 as 1 and 1, then the resultant solution will be like this, and which is a particular solution. Why it is a particular solution? Because it is solution which satisfying a particular physical condition. It is not general solution. It is a solution in a particular context. So this is particular solution. In mathematically, so a solution is said to be particular solution if the arbitrary constants are assigned to some numerical values. So there are general solutions, particular solutions. General solution involves arbitrary constants. Particular solutions gives the values of arbitrary constants. Particular solutions involves the values of the arbitrary constants. Now we will see the following types of differential equations in our unit 3. What are those? Variable separable, homogeneous, linear, Bernoulli, exact, non-exact. These are the different types of first order, first degree differential equations we will see in this unit.